logarithmic function. Every exponential function f of x equals a to the x is a one-to-one function by the horizontal line test and therefore have an inverse function. The inverse function is called the logarithmic function with the base a and is denoted by log base a of x. Let a be a positive number with a is not 1. The logarithmic function with base a denoted by log base a is defined by log base a of x equal y, or this is equivalent to say a to the exponent y equal to x. So a to the exponent y equal to x. So log base a of x is the exponent to which the base a must be raised to x to give x. So the graph, so here we have the general shape of the graph of logarithmic function. The graph of y equal log base a of x is obtained by reflecting the graph of y equal a to the x about the line y equal x. The domain is x greater than 0, or this is in interval notation from 0 to infinity, and the rank are all real number. Some common log that we need to remember. The logarithmic with base 10 is called a common logarithmic and is denoted by omitting the base. So if I say log of x, is automatically understood at log base 10 of x. Express the equation in the exponential form. So log base 3 of 81 equal 4. This means 3 to the 4th is equal to 81. 3 to the 0 equal 1. So ln is the form of log in base e. So log base e of x plus 1 equal to, this means e to the second is equal to x plus 1. This is z to the first equals z. Let's express the equation in logarithmic form. So remember, log base a of x is equal y. This means a to the y is equal to x. So in this case, we're looking at log base z of 2 is equal log base z of 36 is equal to, so let's double check, z to the second equal 36. Log base 4 of 0.125 equal to negative 3/4. Log base 3 of w equal 5. And log base e of t equal to 0.5x. Log base e we can rewrite as ln or natural log of t is equal to 0.5x. We talk more about the natural log in the next section. Property of logarithmic. So log base a of 1 equal to 0. Log base a of a equal 1. Log base a of a to the x equal to x. Log to the x. So a to the exponent of log base a of x is equal to x, and the reason is given. Evaluate each expression. Okay, to evaluate in this, I let this equal to y. So I can rewrite this as, well, 7 to the y is equal 1 over 343. So to what exponent I must raise 7 to in order to get 1 over 343. So note that here we have a fraction, so the exponent y gonna be negative somehow, right? So then 7 to the y is equal to 1 over 7 to the third here. Okay, this means 7 to the y is equal to 7 to the negative 3. This means y equal to negative 3. The next one, that is equal to y. 3 to the y equal 27. Okay. So 3 to the y equal to 27 is 3 to the third. So then y equal 3. In the next case, 64 is to the y is equal 1/4. So then we want to write this into the base of 4. So this is 64 to the y is equal 4 to the negative 1. Okay. And somehow we need to write 64 in terms of 4. Well, then this is the case. 64 is 4 to the third. So now 3y equal to negative 1. This means y equal negative 1/3. Since we didn't write what base is, we automatically assume that it's base 10. So 10 to the y equal to 1000. So 10 to the y is equal to 10 to the third. Y equal 3. So again, first here we will try to rewrite this result in the given base, and then solve for y. Solve the logarithmic function using the definition. So this telling us that, well, 3 to the negative 2 is equal to x. So x equal 1 over 3 squared, that is 1 over 9. X to the second equal to 25. So then x equal to 5. So let's get the graph of logarithmic function by either plotting point or transformation. State the domain and rank of the function. I'll go ahead and sketch this using the plotting point. So when we plot in point, we pick the value. So here's x. Is y equal to log base 3 of x. Note that in this problem, it is a lot more easier to pick the value for y and then calculate in x. We use the fact that log base 3 of x equal y. This means 3 to the y is equal to x. So if we pick the value for y, it's easier to calculate the exponent than to calculate the root. So I go ahead and pick the value for y. So let's say if I pick y equal to negative 2, negative 1, 0, 1, and 2, I can calculate the value for x as follows. 3 to the negative 2 equal 19. 3 to the negative 1 equal 1/3. 3 to the 0 equal 1. 3 to the first equal 3. 3 to the second equal 9. So I can plot this point much easier. So let's go ahead and sketch this graph. So x go to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. When x equal 9, y equal 2. So let's label this value 9, 2. 3, 1. 1, 0. Negative 1, a third. Negative 2, a 9. So it just go closer and closer to the y-axis. So this is the graph of y equal log base 3 of x. The domain here is from 0 to infinity. The range here is from negative infinity to infinity. So note that here we have the vertical asymptote at x equal to 0. Let's take a look at the second graph. Again, I'll rewrite this y equal log base 2 of x minus 4. So I can write this 2 to the second equal x minus 4. So if I just go ahead and pick the value for y, I can go ahead and easily calculate the value for x. Or what I'll do is I'll go ahead and sketch this graph based on the transformation of the log the base 2 of x. Here what I actually would do is to sketch the graph of y equal log base 2 of x minus 4 based on the graph of y equal log base 2 of x. Okay, and now I know that the graph y equal log base 2 of x minus 4 is shifted 4 units to the right of y equal log base 2 of x. So I'll go ahead and sketch the graph of y equal log base 2 of x, and then we'll use the transformation. So here I know that 2 to the y is equal x. Again, I make the table value. I pick the value for y and calculate the value for x. So let's start with this graph. So 1/4 negative 2. Negative 1/2. 1 0. 2 1. 4 2. So this is the graph of y equal log base 2 of x. So now if I use the transformation, I move everything 4 units to the right, I'll get the graph of y equal log base 2 of x minus 4. I move 4 units to the right. So now that the graph of y equal log base 2 of x have the vertical asymptote at x equal to 0. So when we move 4 units to the right, the vertical asymptote of log base 2 of x minus 4 is at 4. So here we have the vertical asymptote x equal 4, and move all of this to 4 units over. So this is y equal log base 2 of x minus 4. We have the domain is from 4 to infinity, and the range is from negative infinity to infinity.